Good day. For those of you who do not know us, we're the instructional staff for EC 150, Professors Hiren Patel and Werner Dietl and Douglas Harder. In this topic, we're going to discuss the structured programming theorem. In this topic, we will begin by reviewing the concept of a theorem which you've already been introduced to in secondary school. We will review the statements we have seen so far, including conditional and repetition statements, that is, if statements and for and while loops. We are then going to look at how to solve a problem using these statements, as well as using something called a Goto statement. Now, we will then describe some problems which are solvable, and we will also look at an unsolvable problem. An unsolvable problem is one that we cannot solve using a program. However, what we will see is next is the structured programming theorem, which will say that all solvable problems can be solved using what we have seen to this point, conditional and repetition statements. We will then discuss how you will use the structured programming theorem when you author programs to solve the problems that we will present to you in this course, and when you tackle problems throughout your academic and professional career. Now, you've probably used and observed many applications, some of which are very impressive. Whether or not it was 40 years ago when people were playing the game Joust, or today when Fortnite came out less than half a decade ago. You may ask yourself, how can we program something like this? Well, the one on the left may be easier, but the one on the right is a little bit more complex. The answer is we're using libraries, but more importantly, we're using the structured programming theorem. Now, the C++ programming language is very complex, and for many and good reasons. There are so many features in this language designed to support the development of software. The C++ standard itself costs around 200 Swiss francs and is over 1,600 pages long. Fortunately, most of you will never master the entire language, and that's okay. None of the instructional staff for EC 150 has either. Now, in your mathematics courses that you saw in secondary school, you've already been introduced to a number of theorems. A theorem is a statement that must be true if the given premises apply. Some examples are Euclid's theorem. There are infinitely many prime numbers. A prime number being any positive integer that has only two divisors, 1 and itself. The Pythagorean theorem gives a relationship between the sides of a right-angled triangle, and this theorem only applies if it is a right-angled triangle. The remainder theorem. If you have a polynomial and you divide that through polynomial long division by a factor of x minus r, then the remainder is the polynomial evaluated at that point r. The factor theorem says that a polynomial has a factor x minus r if and only if the polynomial evaluated at r is 0. That is, if r is a root of that polynomial. Now, up to this point, we've described conditional statements, repetition statements, including for loops and while loops. Together, we've also described arithmetic, basic comparison operations, and logical operations such as and, or, and not. You may be aware of other things in programming languages already, or perhaps not, but we will be looking later on in this course at functions, arrays, and object-oriented programming. But this isn't necessary for a program. You may have heard of something called the Goto statement. It's another concept that appears in C++. Now, on the left-hand side, we have an algorithm that uses while loops and conditional statements. Now, we haven't covered arrays yet, but this essentially sorts the entries of an array. Basically, think of it this way. I've got a list of objects, and I'd like to order them from smallest to largest. Both of these algorithms do it. On the left-hand side, you see that we have a while loop, and as long as capacity is greater than 0, this is going to execute. Inside that while loop is another while loop, and this while loop executes as long as k is less than capacity. Finally, in here, there's a conditional statement which compares max and an array entry. The code on the right-hand side does the exact same thing, but it uses a Goto statement. So, for example, when we reach this point in the program, we jump up here. When we reach this point in the code, we jump back up to here. So what's essentially happening is sometimes we jump from here to here, other times we jump from here to here, but only if certain conditions are true. The code on the left-hand side is a lot easier to understand because it's two while loops and a conditional statement. Here, on the other hand, on the right-hand side, if we start using a Goto statement, we start getting something that is called spaghetti programming because we're just jumping all over the place. Even the Jet Propulsion Lab, JPL, located in Pasadena, California, has this one very simple rule. The Goto statement shall not be used. Remember that JPL is the organization that creates a number of satellites and other spacecraft, including Spirit, Opportunity, and the Curiosity Mars rovers. So you may ask yourself, I could restructure the program's flow, or I could use one little Goto statement instead. Hey, screw good programming practice. How bad can it be? Go to main sub 3, compile. Now, why did I just introduce the Goto statement? We're never going to use it in this course, and if you do use it, you will fail. However, the reason is we are going to try to solve problems through programs. And the question is, what problems can be solved using programs? Now, here's one. Finding the least expensive path between two locations. And least expensive may be least expensive in time or least expensive in cost. For example, fuel costs, toll road costs, etc. Given a set of packages, each of which has a given volume, mass, and a potential profit if delivered, and given a truck that can hold a fixed amount of mass and volume, what is the optimal selection of those packages to carry? Because you may not be able to carry all the packages in that truck. In visiting n cities, what is the least expensive sequence in which to visit them? And again, least expensive may be least amount of time or least cost. Given n integers, is there a subset of these integers that sum to 0? So let's say you have 50 integers. Is any subset, can you take any of these such that the sum of those equals 0? You may be able to come up with some way of solving such a problem, but we'd like to solve such a problem with a program. And these algorithms are necessary in applications such as cryptography. Given n people, of which everyone is known to someone else in that group, but no one is known to everyone, what is the smallest subset of these people so that everyone knows at least one person in this subset of people? Again, this describes a problem which we'd like to find a solution for. And there are different problems throughout computer engineering that can be reformulated to this problem. So if we can solve this problem, we can solve similar problems. All of these are solvable problems. In each case, we'd like to write a program to solve these problems. Now, are there unsolvable problems? Well, here's one example. Given a program with a particular set of inputs, will that program go into an infinite loop? Now, sometimes it's obvious. Here is a program where we query for an input value n, and then I run a loop. Now this loop runs from k going from 0 as long as k is less than 10. However, each time k is incremented by the value n that was provided by the user. If n is equal to 0, this loop will never terminate. Interestingly enough, if n is negative, you may think it will never terminate, but later on in this course we will see that while it may run for a very long time, it actually will terminate at some point. We will discuss this later throughout this course. But the important point is, here it's obvious. If n is equal to 0, this program will go into an infinite loop because the for loop will never terminate. The problem is, it has been proved that this problem cannot be solved with an algorithm. It is impossible to take a program, look at it, and determine deterministically whether or not, given a set of inputs, that program will or will not go into an infinite loop. So there are some problems that are solvable, and there are some problems that are not solvable. However, there's one beautiful theorem which states any program that can be written using only conditional and repetition statements. That essentially says you now have all the tools necessary to solve any problem in the world. Conditional statements and for loops and while loops. Therefore, you have already all the tools you need to solve problems. Everything else in any programming language simply makes it easier to solve those problems. Also, when you learn a new programming language, the first thing you must understand is how to write conditional statements and repetition statements, be they while loops or for loops. So, for example, suppose you were learning MATLAB. Well, first we see that a conditional statement is similar to that in C++, except you don't need the parentheses or braces. Instead, you have if some condition, you do something until the keyword end. A while loop is similar. Again, you do not need the parentheses or the braces. Instead, the body of the while loop continues until you see the keyword end. If you wanted to execute a for loop where k goes from 1 up until 10, you would use the notation here, which is very different from a for loop in C++, but in MATLAB, this runs a for loop with k taking on the values from 1 up until 10. Also, When you tackle a problem where you are given a problem to solve, always think in terms of while loops. We must perform this set of instructions while this condition is true. So the moral of the story is you're not going to be required to investigate the structured programming theorem in this course. You simply have to know its details. Use the structured programming theorem as a guide to authoring programs. If you have a problem that you're trying to solve using a program, always think in terms of looping while some condition is true. Always try to determine when you need to terminate that loop, whether it be with the condition being false or perhaps with a break statement. Always ask Boolean valued questions, whether or not it is for a while loop or a conditional statement. Following this topic, you now have been introduced to the Goto statement, but you also understand that you should never use the Goto statement in a program. It's not necessary. Instead, you now understand the consequences of the structured programming theorem. All programs that can be written using only conditional and repetition statements. If, while, and or for. So, throughout this course and throughout your career, if you are ever trying to write a program to solve a problem, always think in terms of executing a body of statements if or while some condition is true. Here are the references, acknowledgements, the colophon, and a disclaimer. Cheers!